Hey guys, in this video I'm going to solve this problem regarding quadratic functions. So here we are given a function f of x equals x squared plus 2x minus 3, which is quadratic. It makes a parabola. Part of that parabola is shown here. We are asked to find the 3 points indicated on the diagram, P, Q, and R. So just a little word about what these points are. P and Q, as you can see, are points on the x-axis. The points on the function, they're the points where the function crosses the x-axis. We will sometimes call these the roots of the function, or the roots of the equation. So that's what we're being asked to find here with P and Q, the roots of the function. Point R is the point where the function crosses the y-axis. We might call that the Y-intercept, of the function, or the value of the function when x is equal to 0. So when the x is equal to 0, the function has this value here, r. So those are the 3 points we're going to be finding today. So I'm going to start by finding r. I'm going to start with finding r, which is the y-intercept. So like I say, the y-intercept can be found by letting our x value equal to 0. That's how we find the y-intercept. So I am given f of x, I'm going to find f of 0. So f of 0 is 0 squared plus 2 times 0 minus 3. So that is 0 squared plus 2 times 0 minus 3. And so that is 0 plus 0, and I'm left with minus 3. And that constant term that I'm left with here at the end, that is my y-intercept. That is my point R. So pretty straightforward. My r is equal to negative 3. My r is equal to negative 3. All right, and so I now just need to find P and Q. Like I say, P and Q are the values of x for which the function is 0, otherwise known as the roots of the function. In order to find P and Q, I'm going to use the quadratic formula. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. This will solve or find the roots of any quadratic function. The a, b, and c in our quadratic function are the coefficients on our x squared, x term, and our constant, respectively. And so my a value here in this formula is the coefficient of my x squared term. In this case, that's 1. My b, again for my formula, is the coefficient on the x term. That's 2. And finally, my c right here is my constant. That's negative 3. And so I simply input these values into my quadratic formula, and that will give me my roots of my quadratic. So inputting minus b is minus 2 plus or minus the square root of b squared, that's 2 squared, minus 4 ac is 1 times negative 3. 1 times negative 3. And all of that all over 2 times 1. And so I have minus 2 plus or minus the square root. 2 squared is 4. I have a minus here and a minus here, so that will give me a plus. 4 times 3 is 12. All over 2. So I get minus 2 plus or minus the square root. 4 plus 12 is 16, all over 2. And so that's minus 2 plus or minus the square root of 16 is 4, all over 2. And so I have 2 solutions. Solution 1 is minus 2 plus 4 all over 2. And solution 2 is minus 2 minus 4 all over 2. Minus 2 plus 4 is 2 all over 2. That's equal to 1. That's my first answer. My first solution, or my first root. Minus 2 minus 4 is minus 6 all over 2. minus 6 over 2 is negative 3. And that's my second solution. And so, clearly, this is on the positive side. This p-value here is 1. So this here gives me that p, I'll put it up here, p is equal to 1. And clearly my q is on my negative side, so q is negative 3. So q is equal to negative 3. And so I have found p and q, and I have found or, and I have completed my question.